This is a question from Class Activity 12, number 22 on the Sapling assignment, and it's a multi-step synthesis, and the student was concerned that if they, didn't have this bank of different reactions, that they would have a hard time pulling them up. So I wanted to talk about both the strategy for solving a problem like this and also a way to try to remember reactions. So on the test, one of the things that is going to be on the first page or two is going to be a whole bunch of things that look like this. You're going to have a reagent, you'll have some starting material, you'll have some reactants, and then you'll have a box here where you'll need to draw in the product. So here in the first step, I have sodium amide. I know that's going to deprotonate to give me this acetylide ion, and then this acetylide ion can react with CH3 Br methyl bromide to give me 2-pentyne as my product. Now, for a question like this, you don't have to draw all of this out, you just need to draw the final product. But you're going to have a number of questions like this, and then that'll help remind you, okay, here are the different reactions, and then later on in the test you might be using those reactions to do a multi-step synthesis like what's going on in question 22. Okay, so the first thing you want to look at is you notice that your product here has 1, 2, 3, 4 carbons, and your starting material only has 2 carbons. So that's telling you you're going to need to extend the carbon chain by at least 2 carbons. So that is one of the things you need to be thinking about. So far, the only way that you know how to extend the carbon chain is to react a terminal alkyne with sodium amide, and that's going to deprotonate, which will give you this acetylide ion, okay, which you know is going to be a good nucleophile. Now what you can do is you can react that nucleophile with a primary alkyl halide in an SN2 reaction, and I need to extend this by 2 carbons, so a good primary alkyl halide is going to be some ethyl halide, and I see that I have this as one of my options, the bromoethane. I could use iodoethane or chloroethane, it doesn't matter, but that is going to react in an SN2 reaction to give us this molecule, which is 1-butyne. Okay, so now we have our 4-carbon chain, and we know that we can add HBr to the alkyne, and it's going to add 2 times. It's going to do Markovnikov addition. Now we know we probably want to keep that in the dark. But it's going to add 2 times, so we need to have 2 equivalents, or 2 moles of it for every 1 mole of the alkyne, and that's going to give us our final product. So when you're doing, just one other thing, when you're doing these reactions, or when you're doing these exercises, you need to not just focus in on dropping things in the boxes. One of the things you need to do is you need to do what I've done here, is write out all the steps so that will help you remember what's going on in these reactions.